Hi everyone, and welcome to lesson 20-1, the first lesson of second semester that's starting on page 283 in your Springboard book. You are definitely going to want a pencil and probably a calculator today for today's lesson. We are talking today about Pythagorean Theorem specifically. We've talked about it a little bit before in prior lessons last semester, but we are going to kind of specifically get into how to use the Pythagorean Theorem and some wording with it. So notice here they have a kite for us made up of two right triangles. So notice the spine of the kite in this problem is going to be the hypotenuse of our right triangle. So again, the hypotenuse is going to be that spine side xy, right? Segment xy. And then there are two legs. And in this case, the one that's labeled, our two legs are xz, that segment, and side zy. Okay? Those would be our two legs in the right triangle. Now, in order to use Pythagorean theorem, A and B are the legs, C is the hypotenuse, and the setup is going to be C squared equals A squared plus B squared. So if we are going to set this up, if we are trying to find the length of the spine, that's our C squared that we're looking for. And the two leg values, A and B, are 12 and 35. And it doesn't matter which one you call A and which one you call B. C is the one that is specific to being named differently, okay? Now, together, A squared and B squared, so 12 squared plus squared plus 35 squared is 1,369. Now, our C value is currently squared, right? And to undo a square, we need to square root. And normally we would consider plus or minus, but since it's length, we're only going to do plus. So second square root, and then 1,369. Hit enter, you get 37 as your answer. Okay, so 37 inches is the length of our spine. Now, from there, if we move on, there are a couple other questions. So we're going to skip a little bit and we're going to jump to page 284 and down to 5 and 6. Now we see another vocabulary word besides Pythagorean theorem, which is Pythagorean triple. And what a Pythagorean triple is it's a set of three non-zero whole numbers that satisfy Pythagorean theorem. So on this last problem, 12, 35, and 37 would be considered a Pythagorean triple because 12 is a whole number, 35 is a whole number, and 37 is a whole number. So if something's going to be a Pythagorean triple, basically we're saying none of the three lengths have any decimals involved to be a Pythagorean triple. So they want us to check out, are the numbers 3, 4, and 6 a Pythagorean triple? Well, we know the legs are going to be our two smallest sides, so 3 and 4. And we're going to check out, does that equal 6 squared? Okay. Well, we have 9 plus 16, which is 25. That does not equal 6 squared, which is 36. So this would not be a Pythagorean triple because these numbers do not equal each other, right? They don't satisfy Pythagorean theorem. What would satisfy this side note here, and it's a very common Pythagorean triple, is 3 squared plus 4 squared equals 5 squared. This would be a Pythagorean triple, okay? Now, number 6 talks about how we know that C is always greater than A and B, and it's actually going to go back to something we're talking about in the next lesson, so something to keep in mind. A, B, and C are our side lengths, right? And again, C is always the longest, our hypotenuse. And it goes back to, in a triangle, your two smallest sides have to be bigger than the biggest side if you add them together. So even without squaring, A plus B would have to be bigger than C for a triangle to exist. So we'll talk about this more in the next lesson, but that's why C is always the biggest side, because if the biggest side was over here, it would never be greater than this. Okay, so keep that in mind moving forward. Now the other example I want to look at is on the next page, on page 285. We're going to look at not 8, we're going to look at 9. And it says we have a wall with a 24-foot ladder up against our vertical wall. So think about a nice sturdy wall, right? Not leaning, not the Leaning Tower of Pisa here. But we have a ladder up against that wall. And the ladder's not going to lean straight against the wall for us to be able to climb it, safely leaning against it, though. Now, again, we're going to assume we have a sturdy wall that's with a right angle with the ground. So we see Pythagorean theorem being possible here in a right triangle. And we know this ladder was 24 feet, and we see that it is placed 10 feet from the wall. So this down here is 10 feet, and we want to know how high up the wall we're able to go in this problem. So again, because it's a right triangle, that's why Pythagorean theorem is going to be a possibility here. And in order to solve this, again, our right angle is here, so our hypotenuse is going to be the ladder, and then A and B, it doesn't matter which one's A and which one's B, but A and B are going to be our two legs then. So we have 24 squared, C squared, equals A squared plus B squared. And if we subtract over the 10 squared, we have 24 squared minus 10 squared, and that is 476. And then again, like the last problem we talked about, we need to square root in order to get our final answer here. Now, two ways to look at this. If they want you to find the exact answer, again, we need to go back to our list of perfect squares and say, okay, the biggest perfect square that actually is going to go into this is 4. 4 times 119 is going to go into this. And 4 is a perfect square. So we know this breaks down to be 2 and 2 that get to move out of the house. So x equals 2, because that moved out of the house, and then 119 is not a perfect square, so that would be the exact answer, right? 2 times 100, square root of 119. On the other hand, if we were just looking for the decimal approximation, which is what we do most of the time, is square root of 476, we get 21.8 is the approximated value. So that's why we see this little squiggly line is what the approximated value is. So 21.8 feet is what we would have there. Okay, so either of these, whether you're doing exact answer or approximated answer, would work there. Okay. Our last two examples we're going to look at number 10, A and B. Again, to solve Pythagorean theorem, again, you want to identify what am I given. In number 10, you're given the hypotenuse and you're given one of the legs. So in this one, you're going to set this up so that, again, C squared is by itself, then you have A squared plus B squared. And again, we're going to have to subtract this over, okay? Now, 38 squared minus 27 squared gives us 715. Now, again, that's not the answer because that's B squared. Now, 715, we can try and break this down because it says it wants it in radical form. But if we try breaking this down by like amounts of numbers, it's not being broken down. Like we can keep trying to break this down, but actually 715 is not going to be divisible by any perfect squares. Like it's not divisible by 25. That's kind of why I was looking at 5. It's not divisible by 25. There's no other perfect squares that are going to go into it. So actually the square root of 715 is broken down in radical form as this is going to be. We also can look at the decimal approximation of 715, which would be 26.7 would be our missing side, is another way of, if we're just approximating, okay? And then our last one, notice the right angle in this rectangle means that this is our hypotenuse, and then we have A and B. So when you're only solving for the hypotenuse, it's a little bit easier because no subtraction is required. You would just, again, add these two together. 35 squared plus 14 squared would be 1421. And actually, this one does have a perfect square that goes into it. The biggest perfect square that goes into this is 49. So x squared equals 1421. The biggest one that goes into this is, again, 49 times 29. So that's 7 and 7 that move out. So in radical form, after we square rooted, this would be 7 square root 29. Again, most of the time, what we're going to look at for this is the decimal approximation. Square root of 1429 was 37.7. So that would be your final answer there. All right, so we'll work more with Pythagorean theorem in class, and we'll talk about a little bit more also with tomorrow's lesson. Thanks for watching.